Okay, good morning. Welcome back. Happy Wednesday. Today is May 11th. It is our 30th and final lesson of the entire semester. Today we're going to cover solving equations. We're still doing stuff with fractions, but today's things will be equations, whereas the last three classes have just been about expressions. We haven't been solving anything, but today we're going to solve some equations. Not much left in the semester. On Friday coming up, we've got our fifth and final quest, just on the 4 classes, including today's class. Monday is the last day of classes. That's our review day. Our exam is on Wednesday, May 18, 1 week from today, right here in this room. Note the early start at 8 on Wednesday instead of 8:40, okay? All right, questions on the calendar? Okay, so just one quick announcement. The Math Studio schedule, which has been this yellow piece of paper and that you might have a bookmark for, that schedule ends on Monday coming up. It's valid through the end of the day Monday, but starting when exams start, which is Tuesday, May 17, that schedule is null and void and no longer applicable. So if you might be coming around on Tuesday, because our final is Wednesday, but maybe take a quick photo of this thing, or I'll pass around the piece of paper, but this is the schedule for the coming Tuesday in the Math Studio, not the one in yellow, not the one on your bookmark, okay? So I'm gonna pass this blue paper around, just send it around, take a photo if you want, no need to, but let's just get it all the way around the room. And just one last thing, anybody whose name is on this yellow sheet is working in the studio as part of their contract or they're being paid for it. But the folks on the blue sheet are doing it completely voluntarily. So if you work with any of them next week, just say thanks. Okay, so here we are on the top of 254. In this lesson, we solve equations that include algebraic fractions. So there's a little process written out here. We're just going to run through it. In fact, the entire problem is essentially done here. Can you find some blank paper someplace? Could be the last page of this packet or your notebook or something. And we're just going to try to solve this one from scratch. And let's see what we get. Okay, so again, fundamental difference between this and the stuff we've been doing the last 3 classes. What is this? That's an equation. Whereas everything we've done the last 3 classes has been expressions. So at the end of the day, we need to say something like the answer to this equation, the solution to this equation is x equals 5, or x equals -2, or maybe both x equals 5 and x equals -2, all right? So it's a fundamentally different kind of thing. So let us begin. We are going to copy this guy, but give the 2 a big fraction line. We're going to end up completing denominators just like we did in the last few classes. Plus, and then there's a 4 over x minus 2, and give that fraction line a little bit more oomph. We're going to fill in what's missing. Equals 8 over. Now this x squared minus 2x, what might we do to it to write it in another form? We could factor it, and we've been factoring denominators for a few classes now. Whenever we do addition and subtraction with fractions, we factor those denominators. For the same reason we're factoring denominators here, this is the first one we can actually do something with. Again, always look for greatest common factor first. What is it? X. And what's left? X minus 2. So all the denominators are factored, and we gave ourselves some nice big fraction lines. I really think just giving yourself the skeleton of those big fraction lines makes it a lot easier to follow your work. So the goal, just like when we add and subtract fractions, is to make these denominators the same, and hopefully we're going to build the lowest common denominator. So looking at the denominators, I've got 3 denominators here, although one of them doesn't have anything in it. What is this? Let's just look at the second denominator here. What is the second one missing that the third one has? X. So that means we got to multiply downstairs by x, which means bringing in parentheses where there weren't any before. And right away, what do I need to do to balance the scales? Top times x. Don't need parentheses around the 4, but sometimes you might, so let's just put it. What do we notice about the second and third denominators? They're the same. Fantastic. So I feel like all we got to do is make that first denominator match the second one, and the denominators will all be the same. So what is this first one missing? x minus 2, and x, everything. So let's give it both. X minus 2 and x, top and bottom. Okay, so I'm going to write, so all the denominators are the same, yeah? Okay, so the very next equation is going to look far simpler than this one. But getting there requires a little bit of work. I don't want you to copy this. I just want you to use the shortcut after we buy into the shortcut working according to what we're about to do here. What I'm going to do is multiply both sides by this denominator. So you don't need to write this down. But I'm going to multiply the right-hand side by x times x minus 2. If it helps you, it's on top. That's where I'm putting it. And then on the left-hand side, same thing, x times x minus 2. Legal? Multiplying both sides by the same thing. The reason we do that is for the sole purpose of canceling. On the right-hand side, upstairs I see an x, downstairs I see an x. Because it's all multiplication, I can cancel. Upstairs x minus 2, downstairs x minus 2. The right-hand side is simply 8, not a fraction anymore. On the left-hand side, it is slightly trickier, but the same thing happens. Before I do any canceling, this stuff is going to come into the big parentheses and distribute, right? There's a plus sign in the middle. So this guy is going to be next to this fraction and next to that fraction. We buy it? And when it's next to the first fraction, the x and x minus 2 cancel. And I'm just left with what's on top. And when it's next to the second fraction, the x and the x minus 2 cancel, and I'm just left with what's on top. So the nutshell of all of this is that everything in the denominator cancels, and we just get a brand new equation with no fractions in it, which is the numerators. So do copy this down. So I'm just writing the numerators. Do we buy it? Denominators all disappear. Once you have made them the same, they all disappear. But you can't just get rid of them earlier than that, because they weren't the same earlier than that. So once we make them the same, once we do that work to make them the same, we can get rid of all of them by multiplying both sides by that denominator. And I don't need to see the steps, and I don't need to see you cross everything off, but I also don't want it to be magic. I want you to buy into that this is going to work. And so we can just go from crazy equation with all those denominators being the same to the much simpler equation that came from the numerators. And this brand new equation is one that that I could have given you weeks ago to solve, right? It doesn't have fractions in it anymore, so it's just a normal looking equation. So let's finish this guy. So for me, in this first expression, I've got a 2 and an x that I'm going to shuffle to the front and then distribute. Is that all right? 2x and then distribute. So 2x times x is 2x squared. And then 2x times 2, 4x. And then there's a plus 4x over there. And then equals 8. The 4x's cancel, otherwise we'd have a normal kind of quadratic equation with 3 terms in it, and it would either factor or we would use the quadratic formula, but it's even easier here because those x terms cancel. So I get 2x squared equals 8. For most quadratic equations, we want a 0 on one side, but not for these. For these, I want to get the x squared by itself. So if we divide both sides by 2, x squared is 4. And then what do I mean, you probably know what the answer is already, but what do I do to both sides to get x by itself? Is to not square, but take the square root of both sides. That's why I wanted the x squared by itself, so that I could now take the square root of both sides. So I'll put this in a different color here. Square root of both sides. And x equals? Yeah, really easy to forget that plus or minus, but when we put in the square root, when we take the square root of both sides of an equation, we got to put in the plus or minus. so we've got two answers, x equals 2, x equals -2, and we're done. Except we're not done. Because for equations with x's in the denominators, it is quite possible that even though we've done all of this algebra correctly, we're going to get solutions that don't actually work in the original equation, which is quite disconcerting. Because if I gave you something like, like 3x equals 5, and you solved it and you got x equals 5/3, you wouldn't have to worry about whether or not 5/3 works, right? You would just know, hey, as long as I follow the rules of algebra, whatever I get is going to work. And sadly, that's not the case when we have equations with x's in the denominators. So, mandatory to check. So let's check. Let's start with x equals -2. So going back to that original equation way up there. So let me write that equation down here so we have it. So what was it? 2 plus, what's the original? 4 over x minus 2 equals 8. X squared minus 2x. Okay, so this was the equation. I'm going to start by checking x equals -2. We have to do both. So let's check x equals -2. So what do we get here? 2 plus 4 over -2 minus 2, right? Just replace the x with the -2. Equals with the question mark, I don't know yet. 8 over, now both of these x's become -2's. It's really important that we put them in parentheses. So that's the question, changing all the x's to -2's. Okay, let's keep doing the check here. 2 plus, let's see, that's 4 over -4 equals question mark 8 over, this is -2 squared, 4 or -4? It's 4. But without those parentheses, it's -4, which is not the right thing. Gotta have parentheses. So that's a 4, and then -2 times -2, it's a +4, right? Okay, so this becomes 2, and then 4 over -4 is a -1, so that's 2 plus -1 equals, with a question mark, 8 over 8. And now I'm ready to decide whether or not it does. So is that equation true? It is, right? 1 equals 1. Okay, so x equals -2 works. Great. Let's try the other one, which is x equals +2. Okay, so you got the equation in front of you. For me, it's a little bit off the page, but the equation said 2 plus 4 over, and then down here was an x minus 2, right? So 2 minus 2, right? Changing the x into a 2. This is a real problem right here. What's the problem? 0 where? In the denominator. That's a problem. In fact, that's the end of the game. I'll keep writing, but the game has ended. So 8 over, it was x squared minus 2x, right? So 2 squared minus 2 2's. That's the question. Okay, so division by 0 is not allowed, which means x equals 2 does not work. You end up with something undefined when you try to substitute x equals 2. Like I said, it's disconcerting. The solutions were supposed to be 2 and -2. We did nothing wrong. We followed all of the rules of algebra. But it's just the nature of these kinds of equations. When there's x's in the denominators, you might get solutions that we call extraneous, extra. It just don't work. Okay, so x equals 2 is rejected. So coming back over here, the only solution is x equals -2. So that's our answer. Okay, so we'll give you one last time saver here, and then you'll start the activity. Really, when it comes to checking, it's mandatory, because if you tell me the solutions are x equals 2 and -2, you're going to lose points because x equals 2 was not a solution to this equation. But in terms of discovering whether or not it's going to be a solution. You don't actually need to go through the full-fledged check. Like all this stuff in red, we didn't need to do everything. All we need to do is make sure you don't end up with division by 0. That's what the problem was in the down here in purple, right? Division by 0 was the problem. So really, the check isn't check and make sure that everything works out like in this last red line, 1 equals 1. We don't need to go that far. We just need to plug in and check whether or not we get division by 0. As long as you can guarantee we're not dividing by 0, the solution is going to work. And as soon as you see you have division by 0, it's not a solution. Okay, so a much shortened version of the check. Just have to see whether or not you're dividing by 0. Oliver. Yeah, they could both be solutions. Yeah, you could have 2 solutions. You could have no solutions. You could have 2 candidates and they both get tossed out. So then you say no solutions is your answer. Yeah. So all possibilities. There's really nothing we can guarantee. You just have to plug in and see whether or not you divide by 0. Okay, everybody got the shortcut? Okay, so the activity, well, so all of that stuff is written out here, so you can check it out later if you want to. But it's everything that we just talked about. And down here is this important thing. When checking your solutions to equations involving algebraic fractions, it's enough to just figure out whether your solution would result in dividing by 0. That's our shortcut check. Okay. All right, activity is on the next page.